Okay, today we're going to do a quick review of complex numbers to see what we've learned so far. Okay, so here's the number line. We've got our familiar friends on there. We've got 1, 2, 3 and all the natural numbers. We can include all the integers here. If we include 0 and the negatives, that gives us all the integers. We're going to all our fractions in there, 3 on 2, 1/4. All the good ones. Our other good friends, our irrationals. These are obviously not all of the irrationals. There are infinitely many, but they're a couple of favorites. And then we ask ourselves, well, these are all on a one-dimensional line, yeah? So you've got 1 and 2 and all these numbers just forward and back. What if our numbers were in 2D? What if we had a number out here and a whole plane so we could cover this whole thing in numbers? What would that look like? And that's where our good friend number I comes into it, where I is the square root of -1, okay, which gives us I squared equals -1, and then we can continue on our little journey. I cubed is -I because you get -1 times square root of -1. I to the 4 is +1. And then it loops around, so we can keep going I to the 5. That's, what are we up to? We're up to I, yes. Same as I to the 6 is -1. I to the 7 keeps going in this continue. It also goes backwards. I to the 0, and then power 0 is 1, and then I to the -1. We go backwards. We've got 1. We have that -I. This is a really important one. If you divide by I, then that is the same as multiplying by -I. Okay, so that's an important one to know. Alright, let's rub this out and let's see what else we've learnt so far. You can see all the way down there. Okay, addition. Can you see up here? Yeah. Addition. Let's add two complex numbers together. Let's start with u. Right now, every complex number could have a real part, which in this case I'm going to make 1, and an imaginary part, 1i. Let's do another complex number, v. Let's go 1 minus root 3i. Okay, so real part, my imaginary part in this case is -√3. Okay, so you can write that out, but let's just add the two together first. U plus v equals, u is 1 plus I, 1 minus root 3i. Okay, so what? Oh, we're adding these up. Yeah, adding them up. We're not multiplying. Adding them up. So we add the real parts together, 1 plus 1, that's 2. Add the imaginary parts together, I've got 1 minus root 3. So this is 1 minus root 3i. And that's the result of adding two complex numbers together. Alright, that was easy. Let's do subtraction. Subtraction. What do we get? Well, I'm going to go u minus v. So I'm going to change that to a minus. How does this change? I change this to a minus. Okay, so I end up with 1 minus 1. So the real parts disappear because 1 minus 1 is 0. So the real parts are gone. How much, what have I got left? I've got 1 minus root 3. So 1 plus root 3i. So my answer is just 1 plus root 3i. Okay, so just an imaginary part, the real part has gone. So that would be, if we, on our Argand diagram, if we were to plot that point is going to be just on the imaginary axis. So the reals, the imaginaries. We've just got an I there. 1 plus root 3 up. Yeah. Okay. So that's that. Addition, subtraction. Let's do multiplication. Multiplication. Try that out. Okay, so we're going to times u and v together. U times v. This time I can just distribute like I would a normal binomial term. So let's distribute. Here we go. This times this times this times this. 1 times 1 is 1. 1 times negative root 3i is minus root 3i. Then I times 1 is I. I times negative root 3i is minus root 3i squared. Okay, remember I squared is the same as negative 1. So now I'm going to change this, because this is negative root 3 times negative 1. Negative times a negative is a positive. So the real parts, I'm going to group the reals and the imaginaries together. 1 plus root 3 as the real parts. The imaginary parts, I've got 1 minus root 3. So I'm going to have 1 minus root 3 in the imaginary parts. Yeah? There we go. Things with the i's in them. And that's what I get when I multiply them together. Okay. Let's do a specific type of multiplying. I'm going to square the numbers, but I'm going to do it generally. Let's do it generally. Okay. So let's go with green. Green's good. Squaring numbers. Squaring. Okay, so we can write any, generally we use the letter Z to represent a complex number. So it can be any real part plus any imaginary part, y. So real part plus imaginary part, I. Okay, so that could be any complex number. So let's square that number. Z squared, what do we get? We get x plus yi. It's just multiplying by itself. Yi. Let's expand it out and see what we get. X times x. That's x squared. X times yi is xyi. Let's expand this. Plus xyi. Keep going. Plus y squared. I squared. Okay, let's do our simplification. Remember this I squared, that's the same as negative 1. So I've got x squared plus, oh, we can add these like terms up. Got 2xyi, I've got 2 of them. Yeah, and this is going to be minus y squared, yeah? Because negative 1 times y squared. So the real parts, x squared, oh, not a plus, a minus y squared, they're the real parts, plus 2xyi. So this gives us a little rule we can use for squaring numbers. We can just take the x, square it, the real part and square it, the imaginary part and square it, find the difference between them, and I've got that. Got the real part. We can multiply the real part and the imaginary part together, double it, and then we've got the imaginary part. So let's try that out. Let's try that out real quick. I'm going to rub this out, so you'll have to remember this. So I'm going to say u is equal to 1 plus I. No, it's not a very interesting number. Let's go 1 plus 3i. Again, not that interesting. Okay, but that's okay. What? U squared. So to get the real part, I square this number, and I minus them away from each other. So 1 squared is 1. Let's just even fill it in. 1 squared minus 3 squared plus 2xy double 1 times 3i. Okay. U squared is 1 minus 9. 1 minus 9 is negative 8. And then 2 times 1 times 3, that's 6 plus 6i. So there's a quicker way of doing that. If you can remember that when you square, it's going to be the real part squared minus the imaginary part squared, and then double the product of the real part and the imaginary part. Okay, this rule also helps us with square rooting. So instead of squaring, what if you had to square root? Square root. There we go. I don't know why I changed to black, but I did. Square root a number. So I'm going to give you a number. Let's go with, let's call it W this time. W equals negative 3 plus 4i. Okay. So if W equals, what is the square root of W? Oops, there we go, W. What's the square root of W? Well, the square root of negative 3 plus 4i. Okay, so we know that the square root of this, let's let the square root of W be the same as, let's go with P this time. Why not? P. So therefore, we know P squared has to be our original thing. No? P squared is going to be our original thing. Okay, but we also know P is going to be a complex number. So where P is equal to X plus YI. Yeah? P is equal to X plus YI. So if we're going to square this number, we know the real part minus the imaginary part is going to equal 3. And double the real part times the imaginary part has to equal 4. Okay, so we've then got two equations. We've got negative 3 has to equal x squared minus y squared. And positive 4 has to equal double xy. Okay, and then we can solve that simultaneously. Do I have enough room on this side? Might be able to do it over here. If you can see over there. Yeah, I think you can see over there. Okay, so let's have a go. You can solve this any way we like. What's the best way? Well, let's make this equation a little simpler. This is equation 2. This is equation 1. Let's start with equation 2 and go 2 equals xy. And then say, therefore, do it up here, y has to equal 2 on x. Alright, hopefully this will help us. We could also square both sides of this, so then we could say y squared is going to be 4 on x squared. That might help us out a little bit. Okay, so now we know y squared. Let's sub in into 1 and see what happens. Okay, see how this pans out. What do we get? Negative 3 equal x squared minus y squared. Now our y squared is minus 4 on x squared. Okay, let's multiply everything by x squared. See what happens. Minus 3x squared equals x to the 4 minus 4. Okay, so let's put it all equal to 0. X to the 4 plus 3x squared minus 4. Okay, so now we've got like a quadratic situation, yeah? Let a equal x squared. So now we've got 0 equal a squared plus 3x, oh, 3a, sorry. Oh, minus 4. Minus 4. Okay. So what have we got here? We can factorize this to 2 brackets. Let me make sure I get it right. Otherwise, I might be embarrassed. There we go. A plus 4. This equals negative 4. These add together to give positive 3. We're good to go. Therefore, a has to equal negative 4 using null factor law, or a equal to positive 1. Now, we substitute back in our x squared. Oh, running out of space. Pretty much run out of space. Okay. I could go over the other side. No, let's get rid of this. Might need to come back to it, but... Oh, I better keep that original bit there because I'll forget what it is. Okay. So now we've got x squared. X squared is equal to -4, or x squared is equal to 1. Now, we can't have x squared equals to -4 because we're going to get non-real answers there, and x is a real number, and so is y. Y is a real number. It's only when it's put with the imaginary bit that it becomes imaginary. So x and y are both elements of the real. So we can get rid of this as x is in the real number system. Yeah. So we can get two numbers here. We can get x equals plus or minus 1. So if x is plus or minus 1, we can substitute that back up into here. So we can go y is equal to 2 on 1, which is just 2, or 2 on -1, -2. Okay, so we've got two possibilities for our square root. So we're trying to find the square root of -3 plus 4i. There are two possibilities. We could have 1, because that's our x, plus 2i for the y. Or we could have -1 minus 2i. So hopefully when you square both of these numbers, you get w. So the square root has to be either this one or this one. All right. Now, a few other things that I forgot to talk about at the start. Let's just quickly do them, really. I should have done this at the start. I should have done the Argand diagram, what these numbers represent. We sort of started there, but Argand diagram, a few little things that we need to know. So a number can exist on here, our real parts, imaginary parts, complex plane. I'm going to say, like, if we have 1, 2, 1, 2, so 1 plus root 3i, that's our 1 plus root 3i. So you go across 1 in the reals, up root 3. This is where our complex number is. We'll call this number u. No, let's call it z. Z's cool. Let's call it z. We can find the magnitude of z. Usually magnitudes are really easy to find because you, like if you're just talking about the real numbers, because as soon as you know you're at number 2, the magnitude is 2. Yeah, you're a distance of 2 away from the origin. Yeah, or if you go to -2, you're still a distance 2 away from the origin. So the magnitude of that number of -2 is 2. Yeah. However, when you in the complex field, the distance you are away from 0 is still the magnitude, or the origin is still the magnitude, but you have got to use some Pythagoras theorem to solve it. So how far you go across versus how far you go up. Okay, we're trying to find this distance here. So the magnitude of z in this equation, use some Pythagoras theorem, 1 squared plus root 3 squared. Yeah. How far are we away? We are root 4 away, which is 2, positive distance of 2. Okay, we can also find the argument. So the argument is the angle that the complex number is around from the positive x-axis. Okay, now the argument has to be between -pi and pi by definition. Okay, so we've got to get somewhere between -pi all the way around to pi. That covers everything. We don't want to express it as 5 pi on 4, for example. That's greater than pi. So we want to use the negative angle in that case. Yep, which would be 3 pi on 4. Okay, -3 pi on 4. All right, so let's find the argument. So to do that, again, it's just basic trigonometry. Here, we're trying to find this angle in here. We know that this distance is root 3. We know this distance is 1. So we're using the inverse tan. let's call it theta. Inverse tan of root 3 on 1. And if you remember all your exact values, hopefully that should be pi on 3, I believe. Pi on 3 radians of 60 degrees, yeah. Okay, so that's that. What's another thing we have to find? We can find is the conjugate. Conjugate of z. Okay, so the conjugate of z, we use a little line on the top, and that just means you change the sign of the imaginary part. So conjugate of z, 1 minus root 3i. If it was already a minus, you'd change it to a plus. And that's it for the conjugate. Now the conjugate is really important because it helps us to divide when we're, let's do a division. Helps us to divide complex numbers if you're in this rectangular form. So we've been doing numbers in rectangular form. Doing in polar form a little bit later. Okay, so rectangular form for complex numbers. We want to do division. We forgot about division. Let's do division really quick. U equals 1 minus I, and V equals 1 plus root 3i. Okay, let's go with them. Okay, we're going to do U divided by V. U divided by V. 1 minus I divided by 1 plus root 3i. Now the way to do this division is we do a trick and we multiply this fraction by 1. But it's not just any one, it's a specific one, and I'll show you why. So the conjugate of the denominator, so the conjugate of V, root 3i on root 3, 1 minus root 3i. Okay, so this is divided by itself. So you divide a number by itself, as long as that number isn't 0, then you get 1. Okay, so this is a non-zero number, we're multiplying it by 1. This won't change the number, but it has the effect of turning the denominator into a real number. Okay, so if we look at how that expands, 1 times 1 is 1. 1 times negative root 3 is negative root 3. But then we get negative root 3i, and then we get positive root 3i, so they cancel out, and then the root 3i and the negative root 3i become negative root 3i squared. Okay, and that I squared is negative 1. So you end up on the denominator with this squared plus this squared, x squared plus y squared. So I go 1 times 3, 1 plus 3, because it's root 3 squared. So that denominator is going to be 4. Okay, test it for yourself by multiplying them together. Then you just have to multiply the numbers together at the top, the numerators. So I'll get 1 times 1, that's 1. I'll just do this. Minus root 3i minus I minus root 3i squared. Okay, that root 3i squared, it's going to cancel out, make that a positive. So I'll put the 1 on 4th out the front. So I've got 1, 4 out the front. And let's put the real numbers together. 1 plus root 3. And the imaginary parts, I've got minus root 3i. So if I go minus root 3 plus 1i. And it's a quarter of all that. And that's my division. I think that's enough for one video. See how we go in the next video. We might, instead of using this rectangular form, I'll show you the benefits of doing complex numbers in polar form. Okay, see you soon.